Hello! In this video, I'm going to talk about governance and treasury concepts. And we will take a look at the referenda, treasury, and conviction voting pallets. Governance is how the decisions are made in the Polkadot and Kusama networks. It's like the democratic system where the community, composed of the token holders, decides on the important issues such as network upgrades, changes to parameters, or how the treasury funds are spent, defining the vector for development of the ecosystems. Governance in Polkadot and Kusama is decentralized, meaning that all the token holders can participate in the decision-making process. Originally, Kusama and Polkadot were on the Governance1 system. This first version wasn't perfect, and at the moment, both of these ecosystem has OpenGov system. I will walk you through the main points of both of the government systems. So we can see this graph showing us how the Gov1 system looked like. Gov1 was the original governance system used in Polkadot and Kusama, designed to allow token holders to have a say in the network decisions. How it worked? There was a council of elected members who proposed changes or decisions. There was a technical committee that could fast-track proposals if needed. Proposals were voted on by all token holders, and the council had the final say on whether a proposal passed or failed. The Gov1 system was a bit centralized due to the council's significant power. Also, the voting process was relatively slow, with a limited number of proposals that could be voted on at any given time. And there was a queue where only one proposal could be voted on at a time, and the whole voting process for it took about a month. So that system was not perfect and was pretty slow and centralized, as it was mentioned earlier. OpenGov is the upgraded governance system introduced in Kusama and later adopted by Polkadot. It aims to make governance more inclusive, transparent, and efficient. No more council. OpenGov removes the council and technical committee, meaning all decisions are directly in the hands of token holders. Instead of having a single queue for proposals, OpenGov introduces multiple tracks for different types of proposals. Each track has its own voting process and rules. Token holders can continuously vote on proposals using a system called conviction voting, where the weight of a vote is increased by locking up tokens for a longer period of time. This encourages long-term commitment to decisions. OpenGov uses a more dynamic decision-making process where the outcome depends on turnout and the number of tokens voted, making it more responsive to the community's will. Why the change? The transition to OpenGov was driven by the desire for greater decentralization, putting more control directly in the hands of the token holders. By introducing multiple proposal tracks and removing bottlenecks like the council, OpenGov improves the efficiency of the governance process. OpenGov encourages more participation for a broader range of stakeholders, making governance more inclusive and reflective of the entire community's will. Also, in these infographics, we can see the fellowship whitelist. The technical fellowship in OpenGov system takes after technical committee a little bit, and this is a new technical advisory body which plays a crucial role in guiding the technical direction of the Polkadot network. They're responsible for reviewing the technical proposals and making sure that changes and updates to the network are secure, sound, and aligned with the ecosystem's long-term vision. Also, in the infographics, we can see that in OpenGov, the multi-role delegation is available. And previously, in the previous infographics, we can see the delegation was only kind of one-tracked. At the moment, you can delegate not only to the multiple people, but separate your tokens for the different track. So now let's talk about the Treasury. The Treasury is a pool of funds collected by the network to be used for the benefit of the ecosystem. It acts like a community control fund that supports various projects and initiatives that can help improve and expand the network. The Treasury is funded through various means such as transaction fees, slashing, penalties, staking inefficiencies, and other activities on the network. Over time, the Treasury can accumulate a significant amount of funds. The funds in the Treasury are used to support community-driven initiatives that benefit the network. This could include software development, community events, marketing, education, infrastructure improvements, and more. Anyone in the community can submit a proposal to the Treasury for funding. The proposal must outline how the requested funds will be used and how it benefits the ecosystem. To ensure serious proposals, the proposer must put up a small bond, a deposit, which can be partially or fully returned if the proposal is accepted, or burned, destroyed if the proposal is rejected. Treasury proposals are approved through a governance vote. The community, token holders, votes to decide whether a proposal should receive funding. If the proposal is approved, the requested funds are released from the Treasury to the proposer to carry out the project. If there are no valid proposals, a portion of the Treasury funds is burned or permanently removed from circulation. This encourages the community to come up with valuable and beneficial proposals rather than let funds go to waste. How governance and Treasury work together? Governance and Treasury are closely linked, as the governance system determines how the Treasury funds are spent. The community, through governance, decides which projects or initiatives should receive funding from the Treasury. This ensures that the funds are used in ways that align with the community's vision for the network's future. So now, when you have the general understanding of what governance and Treasury on Polkadot and Kusama networks are and how they work, we can come to the conclusion that switching to the OpenGov was a huge improvement for the system. But after a bit more than a year of this system being live, I have to say that I see some room for improvement and for the change for the better. Here are some draft ideas for improvement. Engage more token holders for the voting activity. At the moment, there's a pretty small number of accounts that are voting and making decisions for the whole community. And I can see the tendency that token holders are delegating the tokens and right to vote to some accounts who put their own interests higher than the community interests. And I'd like to see more token holders themselves actively voting for the ecosystem's future. Obviously, some additional motivation is needed because going through all the new proposals and trying to understand what are they about, whether they're worth of the sum of money they're asking for, it takes a lot of time and a lot of effort. So there should be some additional motivation. And building a user's reputation by consistent voting could result in some bonuses, such as higher staking APR, for example. One actor, one vote, or quadratic voting, or some kind of mechanism to balance whales' voting power to the regular token holder's power. Let me know in the comments what do you think about this situation, because on one hand, if the account is holding a lot of tokens, it should have equal voting power. On the other hand, for example, quadratic voting could solve this gap, make it a bit less visible, as the community, previously I told, not voting so actively at the moment. It is really hard to oppose to the voters, to the whales' votes. So it's tricky, but there is an issue in the community at the moment, so maybe there are some decisions could be made on that. KYC, know your customer, plus ZK proof, zero knowledge proof. Unexpected combination, huh? So I was thinking, on one side, KYC would help to avoid spamming and would make voting more secure, while making the voting mechanism ZK proved would make voting more honest and harder to track. So there are a couple of improvements for the big spender track. I would say higher decision deposit would show the dedication and trustworthiness of the people that are taking a lot of money, and also dividing this sum of money into pieces according to the stages of the development of the project would help to keep a track of the activity, and voting on every other stage of the development, whether to give the next sum of money for the development or not, would control these big sums of funds. Restricting the number of referenda for a user, or I would say for project or for the company, because to me, Treasury should be seen at the grant. And when the project comes and shares the idea and it gets the boost from the community, from the approval, from the excitement, and also gets this sort of grant to start the project. But it should be funded on the further stages by some other investors, or they should find some other ways to monetize, probably to be independent from the Treasury. Because at the moment I can see the tendency that the projects are coming counting on the fact that Treasury will be supporting them on the long-term basis, rather than genuinely wanting to make the ecosystem prosper. But the main thing I'm personally concerned about is absence of the strategy for the Polkadot and Kusama ecosystems development. Without the project manager, a particular vector, the community is moving in different directions, doing something what each one of community member thinks is best. That's why ridiculous marketing initiatives without understanding of target audience are funded, but not the talented developers and innovative projects. It would be much more productive to follow the same direction. Or, you know what? Let's count the percentage of the Treasury out of the circulation supply. So if we take Kusama Treasury at the moment. This gives us 1.6% out of the circulation supply. Are you impressed with the numbers? Let's do the same for the Polkadot. (1.2%). This is the percentage which Treasury takes in the total circulation supply of the tokens. So there's a lot of hustle about Treasury spendings recently, but if we see at these numbers, does it really matter? What if the Treasury was burned and the founders would rely on the survivability and self-efficiency of their projects instead of counting on being funded by Treasury forever? I don't know. Anyway, we're not here for discussing these kinds of matter. It's just about giving the basic idea, but also because it's all customizable, and once you're working on your own project and you're implementing the governance and treasury systems in your ecosystem, in your project, you should be aware that there are some issues that can be solved, and the sky is the limit, and something can be done better, relying on the experience of the existing ecosystems. I don't want to sound pessimistic. It's not all so bad. The system works, but there are some issues that can be improved still. In general, this is a lovely opportunity for the people who are interested in making the ecosystems better and getting the support from the community, not only some mental support, but also some financial support. This is amazing. So before going to the Polkadot.js org, let's take a look at the OpenGov terminology and parameters. Origin has a fixed set of privileges. You're setting it while making a proposal, and it's important to choose the right one according to the track. There are 16 tracks in OpenGov, but if we're talking about the Treasury, there are only 6 that allow managing the funds. And they are small tipper, big tipper, small spender, medium spender, big spender, and treasurer, depending on the sum of money that you're asking for. Submission deposit, this is a minimum amount to be used as a refundable deposit to submit a public referendum proposal, so to avoid some spamming. Prepare period, the minimum time the referendum needs to wait before it can progress to the next phase after submission. You can take, as a rule, there are a couple of hours of preparation period, and you can spend it filling in the description of your proposal and putting the decision deposit, which is required for a referendum to progress to the decision phase after the end of prepare period. So, in my understanding, this is when the proposal becomes a referendum. Decision period, amount of time a decision may take. So this is a period of time for the community to vote and to show what they think of this project and the idea. Max deciding, this is maximum number of referenda that can be in the decision period of a track all at once. So each track has its own limit on number of referendas. For example, root has only one referenda at a time because some core changes are made through this referenda. There couldn't be multiple, but on the other tracks there are multiple referendas at a time. Conviction multiplier to increase voting power. This is a powerful tool actually. Approval, the share of the approval vote weight after adjustment for conviction against the total number of vote weight for both approval and rejection. Approval and support. These graphs we will take a look at a bit further. But this is basically statistics on how much approval does your referenda have, and support, the total number of votes in approval compared to the total possible amount of votes that could be made in the system. Minimum approval and minimum support, the threshold needed for a proposal to meet the requirements. Confirmation period, the total time the referendum must meet both the minimum approval and support criteria during the decision period in order to pass and enter the enactment period. As far as I know, there could be multiple iterations, multiple tries of finishing the confirmation period, so probably you have several tries for it. Minimum enactment period, minimum time that an approved proposal must be in the dispatch queue after approval. The proposer has the option to set the enactment period to be of any value greater than the minimum enactment period. We'll see this a bit later. Okay, there's an important table here. We can see all the tracks, and here we can see maximum deciding. This is, as mentioned earlier, number of referendums at a time that can take place on this or that track. Decision deposit, it varies depending on how important the track is, if it makes any changes, any important changes for the system, if it can harm, for example, prepare period. In most of the cases it's 2 hours. Big tipper 10 minutes. Yeah, for the little sums of money, a prepare period is shorter. And for the spenders, 4 hours. Decision period, in most of the cases, 2 weeks, but there are some 7 days ones. Confirmation period, yeah, from several minutes to days. In most of the cases, hours. Minimum enactment period, also pretty short, but for important tracks it takes a day. And there are some graphs, minimum approval and minimum support. We'll take a look at them in the Polkadot org. Okay, so once we in Polkadot org, we go to the Governance tab to see all the related data that we're interested in. Here are referendas. We can see that at the moment there are 8 active referendas. And here we can see the tracks. There's root, 3 referendas in wish for change, 2 referendas in medium spender, and 2 of them in big spender. And below there are referendas, the previous ones. Some of them are timed out, some of them approved, some of them rejected. So before creating a proposal, we can create a preimage. So we need to choose Treasury here, spend local. We put the sum of money that will be asked in proposal, and important moment that here the sum is counted in planks, which is like very tiny bit of KSM, and you need to add 10 zeros to your sum of money you're asking. For example, let's put 1. This would be 100, this number, and this is field ID, and here you set the beneficiary, the account which will get this money in case the referenda passes. Preimage hash, this is what we need to remember. We need to copy it and also take a look at this number, probably remember it. It can be used further, 41 in our case, and submit preimage. The submitted preimages you can find here, as all the previous ones, all in one place. Going back to submitting a proposal. So we're choosing a track. Let it be the small tipper, for example, and there's a hint for every track, how much can be spent. It's 8 KSM for the small tipper and 33 for the big tipper, and so on. So this is how the tracks are different, not only with the sum of money you can ask, but the time of execution, the level of approval and support is different. So you need to know exactly what you... Oh, by the way, if we submitted preimage for 100 of KSM, then it would be small spender. Preimage hash, we insert what we've created and the number of the symbols. Also, here what we've discussed a bit earlier, the number of blocks to delay enactment after proposal approval. This minimum number of 100 of blocks, but you can set your own number if you have any particular preferences, as well as the particular block you want the proposal to enact at. And the submission deposit for submitting the proposal. That's how it's done. Let's take a look at the interface here. So for every proposal on this page, you can take a look at the amount it has asked, the beneficiary address, its preimage. Preimage is saving the metadata of the proposal, because you can see that on the Polkadot org there's not a lot of information saved, because you can see that on Polkadot.js.org there's not a lot of information stored, because the storage for proposals is very lightweight. It saves index of the proposal, and probably we'll take a look at the pallet later, but all the metadata, the preimage we created for, it's stored off chain. We can vote. There's deciding period of time, how many days. who's placed the submission deposit and also who's placed the decision deposit. An interesting moment that decision deposit can be put not only by the origin, not only by the account who's created the proposal, but by anyone. There's some statistics on how the proposal is doing at the moment, and here you can vote. Regarding voting, when you press this button, you see your account. If it's attached to the system, the wallet, well, it should be by this moment. There are 4 options of voting. A, nay. You can split your votes for A on A, but there's no conviction in this case. And abstain. You can put your voice to abstain section in case probably you don't want to take any side, but you want to take part in this referendum and give it a little bit more support. If we vote A on A, there's some of money you can choose, number of tokens you can choose to vote with, and the voting and the conviction rate. So here's the full list of options in this section. If you're voting with 0.1x conviction, this means that you're voting only with 10% of your tokens, but you don't lock your tokens in this case at all. So you're free to do with your tokens whatever you want. If you put all your power without multiplier, just 1x, then your funds are locked for 7 days, but not just for 7 days from this moment, for 7 days after the referenda has passed. When in case it was approved, your funds will be locked for the set period of time here in the conviction section, but if the referenda was rejected, then your funds will be available after the results of the referenda. And the maximum, we can see that 6x is duration of almost 8 or 9 months, which is a lot. And this way you vote. But where's the description, you would ask probably? And I would say here there are UIs, there are external links to Polkassembly or Subsquare. These are UIs for you to use this system to have a good user experience. Personally, I prefer Polkassembly, but it's up to you. You can play with either of them and choose which one works better for you. And on Polkassembly, there's a bit smoother procedure of creating a proposal, which can be done either ways. You can see the button here, and it says that I would need this particular sum of money on my account available for the deposit. Next, it asks if I've created the discussion post, which I did not. People create proposals in the cases that they want to hear the opinion of the community and maybe being pointed out to some issues that can be improved. That's why sometimes it's better to create a discussion first. Here we put a title of our proposal, some tags. You can even choose who do you want to put comments to your proposal. Next, preimage. Well, actually we have the existing preimage. In this case we put all the same that we did on the Polkadot.js org. It is invalid because we didn't finish the creating process. You can select a track. Was it small spender in our case? The same options here. But if we press no, that we haven't created the preimage, it will give us to make it here. Beneficiary address, this would be my address I'm using, but probably you're creating a proposal on behalf of someone, or you want to, for example, give a tip to someone, and you would put the address of the person you want to get the funds. This is the place for that. Here we put the sum of money we're asking, and selecting a track which is here already, and create the preimage. It creates it for you, and then it's pretty much straightforward on this website. Everything's pretty user-friendly. We can see the spend period. This is a very important fact that you might be interested to know, because after the proposal is approved, the money aren't being put on your account straight away. You need to wait for spend period to come, and for Kusama it's 6 days, for Polkadot it's 24 days. Once it passed, then everyone whose proposals are being approved for this period of time, they all will be paid in case there's enough of funds in the treasury. And also we can see the burn here. It's visible in Polkadot.js.org as well. I don't know why you can see it on Kusama. Let's take a look in Polkadot. There's Treasury. And here you can see the number of proposals approved at this time, because this is 24 days. On Polkadot it takes a lot of accounts have the referendums approved, and this is the sum of money which was approved and will be paid out in 3 days and 5 hours. And next burn is this sum of money. Burning mechanism for the treasury is made for keeping the inflation on particular level, but also to incentivize the people who want to propose to be more active, because these are funds for spending. The treasury is particularly for spending, not just for sitting there. And that's the numbers of the treasury. This is what Polkadot treasury has at the moment, but spendable amount is this one, because this sum of money was already subtracted from the available amount at the moment. So let's take a look at the page of Referenda with metadata, how it looks like. And this is actually my Referenda that I've created a couple of weeks ago, and it was approved, which I'm really grateful for. And I was happy to get such a big support of the community. Let's take a look at what we have on the Referenda of the proposal page. In this section, there's actually, if we take a look at the actual proposals that are going at the moment, you can see that there's period of time set here, decision period, which we know is the longest time for the community to show the decision, and there's 6 out of 14 days left for this particular referenda, and confirmation period in this case is 1 day, 24 hours. And in the description section, your description should be ideally very clear, because when people come and they read a long text and some PDFs and Excels and multiple documents but don't get the idea, this is not very good. Although there is AI summary function here which gives you short summary of what's it all about. It was pretty clear for my proposal. It didn't have much information, but for bigger ones it's really helpful. There's timeline and some events that was executed for my referenda. On-chain info, this is basically fields that we filled in. There is decision deposit that was placed and submission deposit. They were refunded. Here on the right, we can see the graph with a percentage of the voters, some ayes and nays, support, and below here we have the voting details with the graph, which we can see in case, well, ideally, if you get like huge support of the community all at the same time, right after you created your proposal, and you get like 100% support with big volume of tokens, then it is possible for your referenda to pass in no time. But this is utopical scenario, and I don't know if it's ever happened. I don't think so. In my case, we can see what these graphs are about, that there was 100% support for 4.5 days, and then some people started voting nay. That's why the graph went down here, and gradually nay votes put the graph down, but still it was enough for the referenda to pass. Here we can see who voted and what was their choice. I would like to say at the beginning, so here we can see that there were 274 positive votes and 113 negative votes. But for me, I'm not upset at all, because if we take a look at the tab of nays, we can see that actually there were only 8 accounts who voted nay. And that is why I'm not upset that there were much more people who voted for my content. And I'm pretty grateful for this support. Let's take a look at the nays again. So, how did it happen that I have 113 nays from 8 accounts? Any guesses? This is because these accounts were delegated with other people's votes. So let's take a look. Here there is an amount of the account itself. So these people are holding these sums of money, and this is their personal conviction. While the total of voting power is the self-vote power plus delegated vote power. And if we open, for example, this one, we can see that there's one delegator who delegated 3K with 6x conviction. This account delegated 3K of KSM with 6x conviction, particularly for this track. And now this account, who these funds were delegated to, can vote on behalf of the person who delegated this sum of money. What is interesting here, that I can see that this account, okay, there are like many different accounts of people who delegated the funds, but for the rest of the accounts there is a certain pattern which I can see with where there are 3K delegated with 6x conviction, only one delegator, and there's the first account we took a look at, this one, and this one. So there are a bunch of them here. The way I see it, that Web3 Foundation or Parity, or I don't know, someone has delegated these votes, because this is pretty standard sum of money for 6x conviction, which is like a huge period of time, to some people who were loud on social media. And now these people are voting, but probably because there's not so much their own skin in the system. They might not always vote in the interests of the community. In my opinion, they put their vision and their perception and their level of understanding higher than like community benefit from this or that project or initiative. So I'm not upset at all about these statistics, because I can see that these are not these people's money, and probably you treat other people's money not the same way you would treat yours if you would be holder with a lot of power. You would be much more interested in the ecosystem development and ecosystem prosperity than just voting to show to the people who delegated to you that you are active on the ecosystem. Probably it would make sense at the beginning, where not so many people were voting and there needed some weight for the proposals for the referendums to pass. But this is the issue. That's why we need more active token holders, not only by delegating the votes, but voting themselves, forming the ecosystem's future by the people who are interested in its development. And there's a statistics tab. And if we take a look, actually, so delegated versus solo voters, and we can see that actually in the A section, in the people who voted for this referenda, there were many accounts also with the delegated power. It shows us how passive the token holders on Kusama particularly are, and because there are only 21k of KSM were voted by the solo holders. We need to grow this number. We need to make people active on the voting procedure. Support percentage, vote distribution, there are accounts that this 18,000's pretty obvious. There are, to be fair, some of them here as well. Thank you very much for your support. Time split, so you can see some peaks. Okay, so some graphs to take a look at. Let me show you really fast the process of delegation if you're interested, because we're already here. It's pretty straightforward as well. Let's start from Polkadot.js.org. We can delegate from here. There's button. There's your account or my account in this case. I can choose a track I want to delegate my voting power to. For example, I know the particular person that is good at making decisions, making some technical decisions, and I would put my voting power to the wish for change track, for example. Or I know that this person has experience with managing big corporations and they know what the ecosystem needs, so I will put my voting power to the big tipper expert. Something like that. That would how I would choose who I delegate to. I can choose the track. I can choose what sum of money I want to delegate, and also I can choose the conviction level. Like previously we saw 6x. If you, for example, if you don't care about those money on the long term, you can let someone else to vote on your behalf and lock your money for 9 months, for example. Or you can choose any of these convictions. or to the all tracks. You can insert the address you want to delegate to, or choose from the list of validators or fellows. There are lists. Now let me show this very process in the Polk assembly, which is pretty straightforward as well. Probably a bit better user experience, but on Polkadot.js.org it's a bit safer to do because you give access to your wallet to on Polk assembly. Probably if you don't want to do that, there are multiple ways of delegating, but also creating the proposals. We can see here dashboard, and basically you choose any account that seems good for you. This is your address set here, delegator's address, you don't need to look for it, the balance, the conviction, basically everything is the same. Selected track, select available tracks, and here we can see all the tracks that exist, for example small spender, and press the button delegate, or you can choose multiple tracks. Here. So finally we came to the moment where I'm taking a look at the pallets that we're interested in. Now we know how the system works, how it looks like on the user's side. We can better understand what the pallets are about, and also we can better understand that almost all the parameters are configurable, and you can use your own settings for your project, like number of tracks and the timing of them and deposits, whatever. It's all configurable. As we know, the pallets are representing some template logic which can be configured in the runtime of your own project according to your needs. So we're taking a look at the referenda pallet, which is for executing referenda but without voting logic in it. Let me remind you the structure of a pallet. So there are imports and config and hooks, storages, events, errors, extrinsics or calls, and runtime APIs. So now let's look at the referenda pallet. There are imports, the config with the types. Here we can see the constants that is all configurable for your own project. You set these constants, max queued, undecided timeout, submission deposit, alarm interval, and tracks preimages as well. This is exactly all that we took a look at some time ago. So there are multiple storages here, the referendum count, which we saw on this website as well, a referendum index, and value query. This type. Also we can see the storage with referendum info, another storage with track queue, the referendas, sorted list of referenda ready to be decided but not yet been decided, ordered by conviction weighted approvals, and we can see the track, this referenda in and bounded vector of the indexes, votes, and the general max number of queued referendas, value query, another storage with a deciding count of the referendas that are being decided on, another storage metadata of, there's a bunch of events, And some of them we saw in the page of my referendum, like submitted, decision deposit placed, approved, rejected, timed out. So, by the way, timeout of the referenda happens when the decision deposit hasn't been placed and it didn't transfer to the deciding stage of the referenda. That's why at some point it just times out because no action was taken properly. Cancelled and killed. This is actually interesting as well. We haven't discussed it, but referendas can be cancelled and killed. The difference is that if the referenda is cancelled, the deposit is returned. But if the referendum is killed, this is some malicious user who's been trying to do some harm to the system, another referendum can be created called killed. And in this case, the malicious referendum deposit is being slashed. This is the difference. Metadata set and metadata cleared. Metadata cleared is very important action, I suppose, not to take some extra space. There are some errors. So what's the difference between events and errors is that events happen in some happy case when something went well according to the plan and there's been a change of the storage. So you've written change to the storage. But in case of an error, this is for the cases that something went wrong, but there wasn't change of the storage. So there are some errors. We can see a hook which does the integrity tests. There are calls, extrinsics that are being called from outside. And here's submit call, where we're ensuring that the origin that executed this call has enough of funds available for the submission deposit, and that is the same account that has created the proposal. Also there's check of the preimage, the len of it, and that the hash is the same. Otherwise there is an error executed. There's check on the track if it's chosen and chosen correctly, that submission deposit has been placed, and we mutate the number of referendums as adding +1. Place decision deposit. The next call, here we require origin, ensure signed by the origin who has created the proposal. We're checking if the referenda is still ongoing and that there is a particular track for it. That's how we know which decision deposit to expect from it, and taking the deposit. The call refund decision deposit. Here we ensure that it's signed by the origin or by the root. Root is the sudo. We check the referendum info, and if the decision deposit has been placed. So now we can refund it once the referenda has its result. This cancel called to cancel the ongoing referendum. Where we're ensuring that it is origin calling this extrinsic. we're making sure that this referenda is still ongoing in order to cancel it. The skill, that cancels the ongoing referendum, but also slashes the deposits. So not only let's take a look, not only, so both the submission deposit and the decision deposit are slashed. So it's better not to be malicious. So this is the function responsible for moving a referendum into its next logical step. It's triggered internally, and it's a part of managing the referendum state progression. The origin, so this is who is calling this function. It must be root in this case. This gets the current block number, and the block number is used to track how long the referendum has been active. We're checking if it's still ongoing and still active. It has had the alarm that has been set to wake this function up after a certain amount of time, and now we're setting it to none and clear the alarm up. So the call service referendum function, this calls service referendum function, which progresses the referendum and advances it to the next stage, takes current block number, the referendum's index, and its current status. And this function returns three values: into, dirty, and branch. If the referendum status has changed, dirty is true, the updated information is saved back into storage so that the system knows about the new state of the referendum. And finally, the function returns the result. It calculates how much computation weight and nudge, so there's weight, which refers to the computation cost of this function. This is important for the blockchain to ensure that all these calls fit in one block, as the block space is limited. One fewer deciding, advance a track onto its next logical state, only used internally. Okay, refund submission deposit, similar to the deciding deposit, decision deposit, where we take the origin and referendum index, check if it was placed, and refunding it. Also depositing the event of who has been refunded and the amount. Set metadata allows to set or clear metadata of a referendum. This checks that the caller ensures that the referendum is still ongoing, ensures that the caller is the original creator of the referendum, ensures that the provided metadata preimage actually exists on chain, inserts this metadata for this particular referendum and emits the event saying that it has been set. The metadata has been set for the particular referendum. If it's been cleared, then we ensure that the referendum is still ongoing, the same, and clear the metadata. If everything checks out and the metadata was successfully set or cleared, it returns a successful result. So the callable extrinsics are over, and now there are not callable functions. Okay, and so on. Checking if the referenda is ongoing, if it's passing, scheduling enactment, setting alarm. This is what we've seen a bit higher in the code. Here's our alarm. We can set the particular interval according to our needs. Okay, there's another function ready for deciding. Next for deciding, not one fewer deciding. Okay. Decision time. So deciding a reference to the current deciding status of the referendum. The tally for this referendum, the count of the votes. Track ID. Track returns a block number. This represents the point of time at which the referendum will be decided. If the referendum is already in the confirmation phase, the function returns the stored block number for confirmation. If it's not yet confirming, the function continues to calculate when the referendum will enter the confirmation or will be rejected. The approval and support levels extracted from the tally based on the track. Until approval, the amount of blocks it will take until the approval level reaches the minimum required threshold of this track, and similarly the number of blocks until the support level reaches the required threshold. Calculating the decision time. Okay. So as an extension to this pallet, there's conviction voting pallet we'll take a look at. And here it says that this pallet is for managing actual voting in polls. This is what the referenda pallet lacks. The same structure, imports. maximum turnout set, max votes, some constants that vary from one project to another. The storage, there are only two storages here. The vote info storage, storing the balance for the number of voters that we have recorded, class voting, and the class logs, the voting classes which have a non-zero log requirement, and the log amounts which they require. The actual amount logged on behalf of this pallet should always be the maximum of the list. Several events: delegated, undelegated, voted, vote removed, okay, and errors. Some checks on the status of the referendum. Let's see the callable extrinsics of this pallet. This vote that allows users to cast a vote in a poll. Origin, as usual, the account calling or signing the calling the function. It must be signed by the user. Index, the index of the poll where the vote is being cast, the actual vote being cast, with which includes both the user's choice, A on A, and their conviction, and the result of executing this function. Ensure signed by the origin, the variables storing the account that signed the transaction. This calls another function, try vote, which will handle the actual voting logic. It passes the three parameters: the user account that is voting, the poll in which the vote is being cast, and the vote configuration that contains some details about the vote and the conviction. Also about the delegating, okay, which is similar. Undelegate, unlock, and remove vote. Okay, pretty straightforward. And now we move into the Treasury palette, finally. So the Treasury palette provides a pot of funds that can be managed by stakeholders in the system and the structure for making spending proposals from this pot. Proposal, beneficiary, pot, spend, these terms should be clear for us by now. Okay, let's take a look. Pallet config, we have currency. By the way, the Treasury can have multiple currencies. The assets logic is used for this. So there could be not only the native token, but some other tokens, because in most of the cases, probably when the companies get the proposers get the native token, they exchange it for example, for paying for some services, and that's not very good for the ecosystem, because the native currency is being sold. So for avoiding selling it, there are sometimes some assets that can be asked directly without then exchanging. Okay, config. Here are the types set. Now we have the storages, proposal count, proposals, number of proposal, and the proposals that have been made, where they store the proposal index and account ID, who created it, and the balance, so the amount that it asks, that is asked. So as I mentioned earlier, pretty lightweight storage. Not a lot about the proposal is stored on chain. Deactivated, approvals, spend count, the count of spends that have been made, spends that have been processed, so probably when there is a queue by the end of the spending period. So this storage is for these cases. Genesis config, which creates the account for this pot for the treasury where the funds are stored. It should have the minimum balance to be activated, so to say. There are a bunch of events. Let's take a look. Spending, awarded, burnt, rollover, deposit, pretty much similar to the referendum pallet, but more about the managing the funds actions. Paid, payment failed, spend processed. Some errors, of course. There's an initialize hook. So this on initialize hook has some logic which is executed at the beginning of the block, retrieves the current balance of the treasury pot, which holds funds that may be spent by the treasury. Deactivated retrieves the balance of any previously deactivated funds. The condition checks the condition if a pot is not deactivated, checks that the current treasury pot balance differs from the deactivated balance. If there are deactivated funds, this line reactivates them, and then it deactivates the current treasury pot balance. So these funds are temporarily put aside, and the newly deactivated amount is stored. The event is emitted. So the spend period, which we met on the UI, how often the treasury spends its funds, and the condition, spend period get is 0, checks if the current block number is the right time for the treasury to spend these funds. Self-spent funds triggers the process of reviewing and approving treasury proposals spending funds from the treasury. If it's not the right block for spending, it returns 0 and not using the computational resources. So there are calls, spend local. This is the kind of spendings that we chose when we created the proposal on Polkadot.org. And now we see that here we're ensuring that This call is executed by the origin. Looking for the beneficiary account and the proposal index. Spending the funds. Remove approval. Force a previously approved proposal to be removed from the approval queue. Okay. There's config for it, reject origin. What's going on here? We find the proposal ID and reject origin. And remove the proposals index from the list. Execute the error, proposal not approved. Spend. This function spend is responsible for approving and executing the spending of treasury funds. The origin who's making this request, asset kind, this is type of asset if the treasury has multiple assets in it. Amount, the quantity of this asset. Beneficiary, the address who receives the funds. And the valid from, this is the block number that is set to minimum 100, but you remember we could set any number above the minimum. So we ensure that origin has authority to propose this spending. Find a beneficiary. Yes, now this is the current block, and valid from. If the starting block is not provided, this is a default value. And the expiration period of time when the funds must be claimed. Native amount converts the asset kind's balance into the native currency. And here's a check of the amount. If the amount requested is within the max amount, the origin is allowed to spend. This section spend requests on max amount to manage spending for different origins. Checks that the new spending amount doesn't exceed the max amount. If it would exceed it, returns an error. Index retrieves the current number of spends made so far, and spends insert the details of this spend, like asset type, amount, beneficiary, valid period, expiration. Spend count is incremented to reflect the new spend, and the event is emitted. So the function payout is responsible for allowing a signed user to claim approved treasury spend within certain limits, and ensures that the spend is valid and hasn't expired before attempting to pay the beneficiary. So we're ensuring that the caller is the origin. Here are the details of the spend using the index provided. If it doesn't exist, there's an error invalid index for this situation. Now is the current block number. Here we're making sure that the current block number is after or equal to the valid from block, meaning the payout is allowed at this time. Otherwise, there's an error, early payout error. Then we ensure that the spend hasn't expired. Otherwise, there's an error. We ensure that the spend is in a state where it can be paid out. It checks if the status is either pending or failed. If the payout has already been attempted, there's an error already attempted. Here we try to make the actual payment to the beneficiary using the Paymaster module. It transfers the amount of the asset kind to the beneficiary. If the payment fails, there's a payout error. After the payment is attempted, the spend status is updated to attempted with the ID of the payment. The updated spend information is stored back in the spend storage. And the event is emitted to indicate the payout, that payout was successful. And it has the spend index and the payment ID in it. Check status call, which allows a signed user to verify the current state of a spend that was previously initiated. If the spend has been processed, it removes it from the storage and emits the appropriate events. Okay, ensure origin, ensure site by origin. Spend retrieves the spend details using the provided index. In case no spend is found, there's invalid index error. If the current block is greater than expired, the spend has not yet been attempted. The spend has expired. And it removes the spend from the storage using spends remove and emits the event spend processed. Oh, and there's no fees in this case, since the spend is already processed or expired. Here we check whether the spend status is attempted. Not, there's an error, not attempted. Paymaster checks the current status of the payment with the provided payment ID. If the payment failed, the spend status is updated to the failed. The updated spend is saved back to the storage, and the event payment failed is emitted. If the payment was successful or the status is unknown, the spend is removed from the storage. This spend processed event emitted, and no fees are charged. If the payment is still in progress, there's an error inconclusive returned, indicating that the payment's result isn't clear yet. The last call, void spend, which allows a specific origin to cancel a previously approved spend. And the cancellation is only allowed if the payout has not yet been attempted. Here we retrieve the spend details using the provided index. If the spend doesn't exist, it returns the error. This checks whether the spend status is either pending or failed. If the payout has already been attempted, the function returns already attempted error. Here we remove the spend from the storage. There's an event emitted, asset spent voided, to indicate that the spend provided index has been successfully voided. Okay. So it's been a lot today. I've talked about the governance and treasury systems in the Polkadot and Kusama networks. There are other projects that have governance system you might be interested to take a look at. But if you're building your own project and you're thinking of implementing governance and treasury, just double check if it aligns with your business logic of the project. Yeah, so I hope this video was useful for you. Bye.